the previous tutorial, we explored Relens Superfish, focusing on how to create virtual pan, tilt, and zoom (PTZ) moves from fisheye lenses. Today we'll shift our focus to LatLong Projections, which are commonly used for VR 360 and 180 workflows, and show how to reframe, reformat, and creatively repurpose this footage using Relens. Important setup notes before we begin. Make sure GPU acceleration is enabled. Be aware that some fisheye footage may not be perfectly centered. This often requires more than just adjusting the radius. And always double check alignment before animating camera moves. Example 1, reframing a 360 LatLong video. Let's start with a simple example. Here we have a 360-degree video shot with a 360 camera. Here are the steps. Apply Relens from LatLong. Set your composition size to the desired output resolution. In the plugin, make sure output size is set to comp size. And then we can animate the virtual camera to follow the action. You'll notice that adaptive sharpening is especially helpful here. Just make sure your viewer is set to 100% resolution to properly evaluate the sharpness. Projection choices. There are two main ways to flatten the image: rectilinear projection and adaptive projection. Rectilinear works well in many cases, but with very wide aspect ratios, distortion can become noticeable. For example, if we zoom out to a focal length of around 0.75, adaptive projection can make the shot feel more like an action camera or a natural wide-angle lens. Switching between rectilinear and adaptive makes the difference very clear. Frame rate tip. Most 8K 360 footage is shot at 24 or 30 frames per second. When this is displayed back on a 60 Hz or higher display, animated virtual camera moves can stutter due to uneven frame cadence, 2 frames, then 3 frames, etc. For best practice, upsample your footage to 60, 90, or even 120 frames per second, matching your display refresh rate. To do this, apply Twixtor, and while you're there, use the source offset slider to remove unwanted frames. For example, the section where the fingers appear close to the lens. Enable Show Source and set offset to around 20 frames. Once retiming is complete, use this processed clip as the source for your Relens reframing. Example 2, reformatting for dome projection. Now let's look at some dome projection. Apply Relens from LatLong to the 360 video. Set the output format to fisheye. And for dome projection, the output is typically a square image. Rotate the view in X, Y, and Z and follow the action naturally. This approach works well for planetariums, immersive domes, and full dome installations. Example 3, projecting fisheye into LatLong. Before we dive in, let's do a quick Superfish recap. Why Superfish works well is because fisheye lenses typically have much higher resolution in the center and less resolution towards the edges. This makes them ideal for front-facing close-ups, subtle camera motion, and shots that would be difficult to capture traditionally. In this example, we're working with close-up flowers. Let's prepare the source. Orient the image so the subject is framed near the edge of the image circle. Rotate Z until horizon is straight. And a helpful trick here is to apply Res Up Enhance at 100%. We can see a comparison with and without Res Up. Now we can set the source lens parameters, noting that the lens is not perfectly centered. Camera position 1, source cleanup. We can enable Show Source. On the right side of the image circle, you'll see the fingers of the person filming. The sky is also heavily washed out. To improve this, we can turn on Layer 1 in the pre-comp, And for illustration, we've filled the missing areas using a simple ellipse shape. This gives us more flexibility when reframing. Camera position 3, zenith shot. Here we show a zenith shot, which is a camera pointing straight up. The goal is to reframe a single fisheye source so it feels like a multi-camera shoot using simple keyframed cuts and different virtual camera positions. One thing to watch carefully is camera height. If the camera is too low, perspective will feel unnatural. Try to place the lens at eye level. Ensure the table or surface is large enough so a 250-degree lens can see it cleanly. Because we zoomed in significantly, we also applied denoise since the camera struggled in indoor lighting. Camera position 2, car sunroof example. Now for a more challenging scenario, this was shot from inside a car pointing straight up through the sunroof, horizontally near 360 degrees and vertically much less coverage. This technique dates back to the 1990s when astronomers used Nikon fisheyes for star mapping. After rotating latitude to straighten the horizon, you'll notice a small black bulge at the top and the bottom. We can switch back to show source, and this is the lens circle being slightly cropped. The sensor height is 13 millimeters, while the lens circle is 14.25 millimeters, which is similar to Ursa Mini 12K. This illustrates an important trade-off: maximum vertical resolution versus full image circle coverage. For reference, lenses like the Intanya HAL 250 series are designed for these extreme fields of view. Stabilization and UV export tips. Because the camera was handheld on a long pole, we stabilized the shot to remove the road bumps. If you need to export distortion UVs, you can switch view mode to distortion UV. But note, stabilization causes UVs to change every frame. To avoid this, switch stabilization mode from keyframed to bypass when viewing UVs. Additional stabilization tips. If the camera is mounted on a car, micro vibrations can occur. The stabilizer respects the alpha channel. You can mask the car hood during stabilization to improve tracking. In visual effects workflows, you may remove the car entirely and replace it with CG, or paste a single clean frame if stabilization would otherwise reveal holes. For simple vibration cleanup, average motion stabilization is often your best option.